You're doing a data analysis, you're using the R statistical program, that's great. But do you also need to code in order to view the data coming out of that analysis? Hi, I'm Pamela Schultz, and this video is going to show you how you can use the R statistical programming language, but have the output from that go into a DataGraph file. The example I'm going to use in this demonstration shows you how to conduct a clustering analysis, specifically hierarchical clustering. This is something that R has many different methods for, and the graphical engine within DataGraph is very well suited to visualizing these results. The video that follows is actually a recording of our 4th webinar in our fall webinar series. It's going to start with a presentation that compares ggplot, which comes with R, to DataGraph, so you can understand the differences between these two approaches. If you already know a bit about both, maybe you want to skip ahead to the part where I do the live demo and I show you how to connect R with DataGraph. So any of you who are new to our webinars, I'm Pamela Schultz, and we have so far Germany, Chile, France here. Fantastic. We are going to be talking about combining the power of R with the power of DataGraph. And the hope I have for this presentation today is to really help to get you started and give you the entry point and understand why this is hopefully a useful functionality and see how it's useful for you. Let me go ahead and share my screen. This is the 4th video that we're doing in our fall webinar series. And this was one that actually people asked for. We did a survey and R plus DataGraph came out on top. And we have a lot of people here today showing a lot of interest in this. So that's great. First of all, why have R plus DataGraph at all? If you're familiar with R, it's a statistical programming language. If you don't have it on your computer now, actually go ahead and you can download it. I'm going to be doing an actual demo after I go through a few slides just to set this up for us. But the thing that most people do, I think at this point, is when they're running things in R, they plot things with ggplot or use some of the native functionality that's within R for plotting. The alternative that we're going to talk about today is combining R directly with DataGraph. What I'm going to show you is how we can have a script that runs in R, and the output from that can directly pipe into DataGraph to allow you in real time to view that output and manipulate it and graph it within DataGraph. You can even have R scripts that are running and generating output, and as it's running, you can view and manipulate graphics and visualizations with that output in DataGraph. Again, all happening in real time. You can sync the two. So what I want to show you is how to connect those two. But before we kind of dive into that, I just want to do a little bit of a quick comparison between ggplot and DataGraph, because maybe not all of you are even familiar with ggplot. And just to kind of make sure we're on a level playing field, I'm sure many of you who are here are familiar with the program already, but I just wanted to, again, do this quick kind of overview here. So first of all, what is the difference between these two programs or approaches? ggplot is a declarative text-based approach to creating graphs. It is a programming language or programming approach, whereas DataGraph is a visual programming language. It's a functional approach. We have a graphical user interface, but there are some things that are similar actually between the two. Just a couple of things to point out here. One of them is that both approaches essentially use graphing layers where you can add different layers and elements into a graph. In ggplot, we use geomes, and there are geomes for drawing paths and points and bars and all sorts of other different types of geomes. And those geomes are collections of drawing approaches that have different options associated with them. And the analogy in DataGraph is the drawing command, where the drawing commands in DataGraph are visual, but we have a plot command that has options related to line plots, a points command that does scatter graphs, a bar command that does various options there. So it's kind of a similarity in that respect. And one of the big differences, however, is that when you're editing a graph, if we're going to edit a ggplot graph, we're going to be rerunning code, whereas in DataGraph, we do things interactively and in real time. And for me personally, this is one of the reasons why I really like using DataGraph, because I tend to want to change things around and make edits and see what things look like, and I can do that all in real time. We're going to be using an example data set for this that is it's called MT cars. Just in case you're not familiar with this, this is a really common data set that's used for doing demonstrations of various aspects of graphing data analysis. So this data set has, 32 different automobiles, and it has all these different variables associated with these cars. This was from 1974, so some of this data doesn't clearly represent modern vehicles, but this is one of the data sets that I'm going to use for this demonstration. So I just wanted to make sure you're familiar with this. And again, to kind of just compare the two, ggplot versus DataGraph, I want to plot this example data set. We're going to create a scatter plot where we're going to use the horsepower as our X. Our Y variable is the miles per gallon, and we want the points to change color depending on the number of cylinders. To do this in ggplot, again, declarative language, we would have a series of commands that we would use, and those commands can be used to generate the output like what you see here. Just to dissect this a little bit, you can see how we have the horsepower, our Y is our miles per gallon. We have this statement here. How do we cycle the colors? We're also typing in things like our titles. The size of our points is set to a larger size to generate this particular graph. This is also using some non-standard colors. So we're specifying the colors in here. If I'm going to do the same thing, or actually before I do that, if I'm going to edit this, what do I need to do? If I want different markers, different size markers, change the titles, I'm going to have to retype my code and rerun it to get a new graph. If I'm doing this in DataGraph, this is what my program looks like in DataGraph, where I don't have to think about the syntax for how I enter titles. There's just an entry box where I put in my titles, I can change my fonts, I can change my marker sizes, and I can do this all interactively. And I just had a quick video to show you that walks through this. So again, I add a command, I can use drag and drop to change these. I have the ability to change the fill based on a variable. I can set up a color scheme based on this. I can go ahead and then add in a custom legend. For custom color schemes, I do have to add a custom legend. And again, I'm doing this all using this graphical user interface. I can type in a title for my legend. So there's a little bit of setup, but again, now it's all set, and I can even do some edits interactively on the screen. Now, if I want to edit my basic plot in DataGraph, I don't rerun code. Here's an edited version of this. Let me show you how this was created. I made a clone of the current graph. This is something I do all the time. Makes it really easy then to make changes and not have them in the original one that I made. I can cycle through different colors. I don't have to type in colors. I can pick from my color schemes. These all come from the Color Brewer website, which has a number of different pre-set up color schemes that are really useful. You can get Color Brewer in ggplot as well, but then you have to remember, the name of the scheme. Anyway, so here's how we would do this editing here in DataGraph and have the same graph, but now with different options. Okay, now let's get into the DataGraph R package to create this connection between R and DataGraph. What we do is we actually create an output file that's an intermediary. And then it's going to be really easy to take that output and have DataGraph view and read that. So let me go ahead and give you an illustration of that. First, where to find information about the DataGraph R package? Well, if you just Google DataGraph R package, you will find help on our community page. I'll show that to you in a moment. This is a package that's on CRAN. This is the network that has all the different packages that are in R. So there's a help document available there as well. And it documents a series of functions that, again, allow you to connect the two programs together. In order to use the package, you're going to have to obviously download R. You can go into your package installer. If you search on DataGraph, you will see our package. I always recommend to install dependencies. That's this little button here. And then once you have it installed, now we can use the DataGraph package in R. You will also, or another option is to install it from the command line. So I just thought I would show you that here. Install.packages DataGraph. And here's a very simple example. So in this example, I'm just showing the saving of a simple data frame that will allow us, again, to connect R with DataGraph. The data frame that I'm using, this is sort of the terminology used in R for a table. We refer to it as a data frame. And to actually create this connection, you do it using data frames. Or something has to be considered a data frame in R in order for this to work. So I have this data frame available in R for the empty cars data set. I need to know the path of where I'm going to output this intermediate file and a name for what I want this intermediate file to be called. And what you can see down below here is the syntax of the function write D table. This is a function that is part of the DataGraph R package. You can see here that you can see here that I have to bring the library DataGraph into memory. Actually, I think I didn't necessarily need this second line there. But how does this write D table work? Well, there's two input arguments. One is a combination string that has the path and the file name. And then I also need to show the data frame that I want to output. And if I run this command on the R command line, a file is going to be output. So here you can see this is just a representation of the file that I output coming from the Finder. And the extension on this file is a dtable extension. This is a file format that is read by DataGraph. And again, this is what the write dtable does. It creates a file that has the data frame in it. And if I then want to get this into DataGraph, one really quick way to do it is just to drag and drop that file directly from the Finder into the DataGraph side panel, and then you've made the connection. You've done it. You now have your data from R connected to a DataGraph file. And it will update automatically. So if any of the data in R changes, then the data that's in DataGraph will change as well. Now, you do need to see the path, and there's a quick shortcut that I wanted to show you that I find really helpful from the Finder. If you have a path object, you have a folder that you want to save something in, you don't know what the actual path name is to get that Unix style path name, you can go into your Finder and hover your mouse over the name of the location, and this little blue file will pop up. And then you can click and drag that and drop it anywhere that text is recognized. And when you do, it will show you the path name. It's a very, very handy trick. So then you can get the full path, and then that's it. The rest of my files are not ones I'm going to show, which is why it says hidden. That's more for me than for you. But in any case, this is the the basic way that it works. Now, what I've talked about so far is just saving one data frame, and I'm going to go ahead now and demonstrate that. But you can save multiple data frames. You can also use a DT binary file, which allows you to have multiple data frames in a single file. But let's go ahead and demonstrate this. Okay, go ahead and go first to, oh, here's the help page. Let me actually put this on the chat. So if you go to this page, it's also going to walk you through the installation and give you an overview again of how this works. There are 3 different uses for the package, from saving a single data frame to a sequence of data frames to a collection of R data sets in a single file. And this has an example using this OST-res data. Again, shows you what do you need to type in to invoke this in R. And then here is the command for writing a single R data set into DataGraph. So let's do one of these. Here we have my R console, and I'm showing you my temp file. I showed you that trick earlier. Let me demonstrate this because I just think this is so handy. I'm going to make a new DataGraph file that has a text block in it. So you see I have my Finder here. I have DataGraph here. I want to output a file from R into this location, but I need to know what that path is. So I'm going to drag. You see how I hover over this? I'll do this again. You see the little blue icon. I'm going to drag this, and I get a green plus symbol when I get to somewhere that will recognize text. If I drop that, it's going to tell me the path name. This one's pretty easy. It's just private temp. But I don't know. I just think this is a very handy thing to recognize because you need that path name, again, also in order to do this in R. So now I go to my R console, and let's try. I'm going to type in, let me make sure I have all my commands. Yeah, I feel like I need another monitor for this because I have a lot of moving parts here. Okay, so I'm going to type write capital D, capital T, ABLE. That's the function I'm going to use. I'm going to do parentheses. Then I need to put in quotes the path name. So I just pasted that in there, and included in the path name is the file name. So let's call this empty cars, because that's the data I'm going to output here. And then I need to put a comma, and I'm going to say empty cars, and I'm going to hit enter. It worked. Okay. Did you see how over here? Here is now the output, the empty cars file. Now, if it didn't work for you, you do have to make sure again that you have loaded the command library to library parentheses DataGraph, and also have the DataGraph package installed. But that's it. Now I've got my dtable file. Now let's go into DataGraph, and let's do a blank file. And how do I connect these? Let me hide this. So here's my DataGraph file. Here's my Finder. I'm going to take this file and drag it. Oops. I'm going to do this. Drag it. Why this doesn't want to drag and drop. There we go. Drag it and drop it right here into DataGraph. And that's it. Now the data is connected. So this is data that's coming from R, but it is connected to my DataGraph file. So this is not doing any analysis. It's just showing you the raw data. Now, again, I could plot this like I did before. I could do a points command. Actually, I want the horsepower for my X, my miles per gallon as my Y. So I can create graphs directly from this data coming from R. All right, now let's do something a little bit more sophisticated. And there's a number of different examples that are right here on this page. I don't really have time to walk through all of these. I really wanted to do this example with the this dendrogram, which is a hierarchical clustering example, to show you how that will work. But I will encourage you to go through this on your own. If I have time, sort of at the end, maybe I can go through a couple of these or talk about this a little bit more. But the examples here on this page will show you, again, multiple ways to use this. But let's stick with our example here to, again, show you the combination of doing the analysis in R and then doing the graphing in DataGraph. So let me go back to my R console, and I'm going to be using, make sure I get this here, a package, in case you don't have this. Yeah, I'll go ahead and put this on the chat. This is a package called GG Dendro. So that's actually the command that I just put on the chat that you could use to install this. I already have it installed on mine, but I'll just go ahead and paste in here. There it is. So you could type that in to install that. So from the chat, it should be pretty easy. You can just, anywhere that I paste the commands, you can go to the right, there's little dots, you can copy that, and you should be able to paste that into your own instance of R. And how would I start this? Well, I can start by making sure I have all my appropriate libraries loaded. So here's 3 commands I'm going to do: my DataGraph library, my GG Dendro library, so I want you to have that, and also setting the data as empty cars that I'm going to use. So I enter these 3. I'll also put those on the chat. Next, to do the hierarchical clustering, I want to, and maybe I should back up just a second and say, what is clustering? What is this doing? Well, we have this data set with all this different attributes of cars. I want to know which cars are like the other cars, and to see where the clusters of cars that have similar attributes are. So that's what this is going to give us. And the first thing we need to do, because we have all these different attributes of the data that I showed you earlier, first thing I want to do is just scale the data for empty cars. So this is a scale function using that data set. So I'm just going to keep putting these on the chat every time I enter one, so you can enter the same one. You don't have to type them. But now I will use the scaled data to create a clustering model. That's the command for that. It's using this H cluster. Paste that also on the chat. Now, what's interesting about doing dendrograms in particular in R is that the output that comes from this, even for ggplot, it's not quite in the right format. So there's this, the package that we're using, this GG Dendro, this allows us to extract data in the format that we would need for ggplot, but it also works for us in DataGraph. So I'm going to paste those 2 commands in. I'll give the same 2 commands to you. So this is taking our model of clustering, creating this dendro object, and then we're taking that and extracting this DD data. This is how we get the data for the dendrogram itself. Now, if you want to just type in plot D data. Oh, I thought that would work. Let me try. Is it plot? This is what I do by going off script, right? Dendro. There it is. Okay, so it's not the D data. That would be actually going into ggplot. But if you plot dendro, it's going to show you this. Okay, so here is the representation of the dendrogram coming directly from R. You can see how here's my cars, the make and model here along the x-axis, and it's showing the clustering between them, so that cars that are located in the same part of the graph within these tree structure would be similar to one another in various ways. But you can see again how, there's things, some of the names are cut off here. This clearly is a graph that we would want to do more work on in terms of being ready for sharing with someone or putting in a publication. So we're going to do this in DataGraph. Okay, so first thing is, again, to set up a path. And what I'm going to do is actually create a path variable that is specific to me. So I'm going to type this in. Now I have a variable with my path name. I'll send that to you as well, just so you can see how you would set that up. So whatever path you want to use for putting your output in, you can type that in there to create this path variable. And then I'm going to use that to there's a paste function within R that allows me to combine the path string with the file name. And I think I've already output. Yep, I've output that. So here's the two commands for writing the output to DataGraph. These are two write D table commands that, again, they're pasting together the path with the name of the file. Before, when I showed you the example, I did it all in one string, but it's convenient to sort of separate out the path in its own variable. And I'll show you in a minute what this data is. Okay, so all the commands that I use now, you should also have in the chat, so you can try those for yourself. And what we did is we output two files. They're actually in this folder, this R folder here, which I have a number of other things in because I've been practicing and creating some options here. So the two things that we created are these two right here, the D labels and the D segment. Now, this is using a specific type of hierarchical clustering model. That's what I specified here in this line. This is using an average approach. There's a number of different clustering models that we can use. I'm going to show you that in just a minute, but let's just draw this. Now, in the interest of time, let me show you one that I made here. This is the kind of thing that I did in DataGraph. So you can see all these various diagrams. I was even able to create this diagram where I used a scalar field to show the dependencies. So you not only see the name of the cars, but you see all of the variables that are being used in the clustering. And it's giving you a sense of what variables are important for the cluster themselves and how these break down. So I don't know if I have the time to go into every detail of how I created this, but let me continue because I really do want to show you. So that gives you a sense of what you can accomplish. Let's see what we can do in the next few moments. So let's make a blank file. And I've got my labels and my segments. These are the two tables that I output from R. And I'm going to drag. I can actually do them both at the same time. Hold the Shift key. For some reason, it just doesn't want to do them both at the same time. Okay, I'll do them one at a time. But I dragged both of these files into DataGraph, and now you can see what the output of these is. And to quickly, for some reason, I really like the labels being on the left-hand side. So here I can see my list of all my cars. And this data here, the D segment data, is what we can use for the clustering. There's a command that's really convenient for drawing this just in the way that it comes out in R. And you can get that under the draw menu. And the command is the connect command. Okay, so go ahead and add that. And what does the connect command do? It lets us specify a beginning XY point and an ending XY point. And that's the format that this D segment data is in. It works perfectly with this. And so I can specify my X, first X, and Y. Now starting to draw my second X. Oh wait, I didn't do the second. This one, second X and Y. And there I have it. Here is my dendrogram. Okay, now this is one way to draw it. This is kind of showing the tree structure. They call this the triangle type of view. If you wanted to draw this in ggplot, you have to use this particular data with that triangle option, if you notice that in one of the commands that I used. But let me show you something that I think is really cool about doing this in DataGraph. So first of all, let's do a Shift Command D to swap my data and my commands. Let's open up the command here to show more options. And in DataGraph, I can use this same data set. I don't have to regenerate it, but I want you to notice this. Oops, sorry, getting a little sloppy here. Not show all my keystrokes. This is what I want you to see, this right here. This option for line type. Currently, it is set to straight, but let me show you what happens if I change this and set it to steps. Now I have the tree structure because DataGraph can draw these connections, not just a straight line, but it can draw it as a stepped line. I can also make it curved, which I think is kind of an elegant way to show my dendrogram. I can also draw the actual points located at each segment where the clustering is taking place and show you the points associated with that. So now I have the connect command and I have a points command layered on top of that. I just want to put a little bit of color in here for now so that you can see that. So what I really want to show you, and of course it always takes more time than I think it's going to take to do all this, but what's really neat about this is that I can rerun now my model in R and it's going to update here. Actually, let me just really quickly add in the X labels. So I can change my X tick marks from being numerical to being labels. We're going to use that label there. Let me put this on space for Y. Oops, sorry, not space for Y. Undo that. Space for X. There we go. So now I have room down there. I can show you. I can have them all listed, and let's go ahead and go back into R. Here's my R console. So in this version, I did the model with the average clustering option. I'm going to change this to use a different option. So the first thing to do is to generate the model. So this is a ward.d2 is the option that I'm going to use here. So this, when I enter this just generates the new model. I still need to output it to DataGraph. So I can use my arrow key to go back to the commands I need to do to run that code. So I'm going to now create the data object with this new model, and I'm going to write this out into DataGraph. So when I hit enter here, it's going to immediately change this cluster to using this different option. So hit enter, and the clustering changed. So again, what I'm trying to illustrate for you is this connection between R and DataGraph. So I could run all different types of clustering algorithms here in my R console. And when I did, it would immediately update the visualization of the data that I can see here in DataGraph. Can I answer any questions for you about this? Yes, question. Will this work with RStudio as well? Absolutely. One thing I sort of like about R these days is how you can zoom in the the commands. I actually probably should have been doing this during the talk so you can see this better. I don't know if you can do that yet in RStudio, but I think it's maybe there is a way to zoom in, but this is kind of a nice interactive zoom in this view. Question, could you perhaps add this example to your online examples in DataGraph? Yes, I think we can. The only thing that will be, certainly we can do that. The only thing that maybe is a little bit difficult is because this again is a connected file. It's connected using this. Let me just show you this a little bit more. These objects. So if you're familiar with DataGraph, you would probably recognize what a group looks like in DataGraph. If I have a normal group, I'll do that. Let me just add in a normal group object of data that's just it's saved in DataGraph has this different icon. Notice how these groups here have a different icon. This is indicating that this is a connected data set. So I can certainly add in more examples of the dendrograms, and maybe, again, this is kind of one that I created that I thought was kind of useful, showing these different options with the MT-CARS data set. I also have these points here that are colored based on the miles per gallon of the cars themselves. And so that's kind of interesting to see. There is a dendrogram example within the example files now, but I realized I don't actually have this format exactly mapped to the format that's coming out of R. So I'm going to update this so that it does. But this I think is really kind of neat, using the scalar field here to add to this. And this, it takes a little bit more understanding of how to do things in DataGraph, but basically this is a normalized set of all of the output, or all the data in the MT-CARS data set, where the variables have to be scaled or normalized so that we can compare them all within the same screen. And then I'm just creating a scalar field based on this. So I have this long version of the table where here's all the variables, all the cars, and to do this scalar field and add this in is just a matter of adding the scalar field command, where I have the labels. Oh wait, no, actually sorry. We have that location where I want the variable that corresponds to the mapping. We have the category as our Y, and the values are here. And that just automatically creates this categorical scalar field for me that I can then integrate into my other graphs. And this is a matter of, for any of you who are new, within DataGraph, you can split your canvas in any multiple ways in either the X or Y direction. So here, for example, if I split in the Y direction, now I can place my dendrogram and my points up on the top axis. Okay, let me pop this over so you can see this a little bit better. And then if I want this scalar field on there, I don't even have to regenerate it. I can drag and drop this command over onto this graphic here. And now it shows me both combined together. And now the other thing to keep in mind, again, is that what I'm showing you, what I've showed you so far, is just using the write dtable function within the R package. But if you go to the help page, so that's just basically example 1 here. Save a single R data set, and it runs through this. If you're having any trouble, I'd recommend going to this page and definitely walking through this. And and you can see how this is using a this is OSRES data set. That I think this must be the population in Australia. And what this shows you is how, again, if I change any of the data, things automatically update. But the other thing is this example 2, saving a sequence of data frames. And you can take any of this code. So if I take this and copy it, again, I would start with making sure I have the DataGraph library, copy that, go into R, make that active. Now I'm going to go to my example 2 here. I can just copy this whole thing, paste that in. Now I have, for me, again, this is set up for my directory. But what this did is it actually created a whole sequence of tables and it output it into my temp directory in the Finder. So it output a file that's just called table. And here it is. And if you wanted to just, you could say open with DataGraph, for example, for these dtable files, if you just want to look at this. And then here is a list of how the population is that I can then just plot this, make a point. But what's different about this example, it is not just one data frame, it actually saved 6,000 data frames into one dtable file. And you see how I expanded this open. There is an index here that I can use the slider and change which data frame I'm using. Now, if you look at the function call that I did within R, all I did was just increment the data by a value of 1, and I did that 6,000 times. That's why there's 6,000 data frames, and they were output into my single dtable file. So this is kind of an interesting use. If you want to do multiple analyses, you could have them all in the same dtable file and then just use this slider to look through the different results and see how they changed. But definitely I would definitely recommend working through the examples that are on the help page. The last example here, the third one, is actually using a slightly different command within the DataGraph package. And this is a command called an add DT bin. This creates a DT, a binary file, the DT bin file. Actually, I can just run this myself really quickly just to illustrate. So I'm just going to copy this. I'm going to go to my R console. Let me actually show the Finder window at the same time so you can see what is being output. So I'll paste this in my R console. It's going to output a file that's called combined. So there it is. This has the extension DT bin. This is different from the dtable because dtable basically contains a table where you have a set format that can have multiple, again, a sequence of tables, but they would all have the same format. In the DT bin file, now this one doesn't have the right click. Let me just do I can do the same DataGraph file. Let me drag and drop this into here. So now I can see what's in this DT bin file. This is 2 different data frames with different tables in them. So I have a table frame a data frame called women and a data frame with the OSTRES data. What I think is really interesting about this is you could have an analysis where you have multiple tables of different types. You could have your input data, your output data, intermediate data. You could have it all saved into one DT bin file, and then just drag and drop that whole file into DataGraph to be able to view everything that's in there, and also could serve as documentation of what you did in an analysis. Again, having everything in there in multiple tables with different sizes and shapes. Thanks for watching, and if you've gotten all the way to the end here, then I hope it's not too much to ask to like the video, subscribe to our channel. We will definitely follow up with more on this. We had some great suggestions at the end of the presentation during the Q&A on some other things that we could provide to you in terms of example files. And we've got some other ideas brewing in our heads as well as to some things that we could do related to this. So thanks again, and until next time.